My name's Greg. I work for Relay, and I support Mr. Campbell and other leaders across the county to kind of help with their leadership and help you all grow as teachers as well. And so what we're going to do today is something that I don't think you all have ever tried before, which is called a weekly data meeting, where you essentially just look at student work from one of your classes, from Seth's class. And the goal of this meeting for us is to figure out what this task is asking, what the standard is asking for, and then to look at the student work and figure out how they did. And then once we figure out where students struggled, my goal is by the end of this time together, you're going to have a plan to reteach it. So you have a plan to help the students who didn't understand. So that's the goal, is to come up with a reteach plan that you can take back to your classrooms. And then Mr. X, if this is something that your students struggled with as well, then you can take it back. And so you're essentially going to leave with like a short lesson to fix any errors that we had in the student work. And so this is just so we're clear, like this is like us working as a team, right? This isn't like a gotcha or like why didn't it work? This is like, let's look at student work together and figure out how we as a team can figure out how to help your students as best as possible. Sound okay?
Yes, sir.
All right, so I'm just gonna guide you through it, and then I'm gonna keep notes up here. And then you all have, you have a blank version of it, but I'll keep our notes up here so we can all get to everyone see that, okay? Okay. Well, first of all, just thank you for coming. Usually, if we had been on a cycle of weekly data meetings, we'd have some old stuff to look at. But since this is the first one, we're just going to dive in and look at the standard. And so today's meeting is about standard NC M1FIF2, which you can see, which is to use function notation to evaluate linear, quadratic, and exponential functions for inputs in their domains, and interpret statements that use function notation terms of a context. So the first thing I'm going to ask you to do is, when you look at this standard, just to take down some notes in your own words. What do students need to be able to know and do to master this standard? So you can take notes anywhere that you think. If you're trying to come up with what should students know or do to show mastery of this standard. I'm going to pause you where you are, and we're going to talk about it together. And so what we want to do when breaking down standard is split it up into what students need to be able to know, which is like what they understand conceptually, and then show what you might see on their papers to demonstrate that understanding. And we have some ways we can break it up. So we have like vocabulary they might need to know, and then concepts they might need to understand, and then any ways you want them to annotate around the standard, and then how you might see it show up in the writing or problem solving. So did anyone think of any vocabulary that students might need to know as they go through the standard? What's that?
Function.
Function, yep.
Evaluate.
Evaluate.
Function notation.
Yeah, function notation.
Domain. And then range.
Mm-hmm.
And then they have to know
And then there's another vocabulary piece, another way for domain and range, like what's another way you call the X?
Input,
Yeah,
Input and output.
and output, great.
independent, dependent.
Yeah. So a lot of different ways to say the same thing. Okay, awesome. So we've got the vocabulary that we think that they're gonna need to know. Then conceptually, what do they need to understand about functions?
So a function is, you have your x values that correspond to a specific y value.
Mhm.
So
Yeah.
like one-to-one functions.
Right, because we know it's not a function if it has more than one output, right?
Yes, sir.
So x value corresponds specifically to one y value or like one input for one output, right?
Mhm.
Okay. What else?
They have to know that whenever given a function and asked to evaluate, they have to know that whatever the value they're evaluating that has to replace that x value or that x variable inside the parentheses.
Mm-hmm.
So if it replaces that variable inside the parentheses, it needs to replace it also in that particular expression.
So how do we say that?
So, yeah,
Substitute,
yeah.
Substitute, so like know how to, so although that might show up, would that potentially show up over here in what they would show, right?
Okay.
Which let's put in, right, that they have to basically use substitution. And I'll make sure you all get a copy of this too, but yeah, but feel free to read it. And probably have a lot of typos in it, so I'll try to clean it up. So use substitution, how would you say that,
So use substitution to,
So, yeah, so basically the x is the input.
right,
So if you ask to evaluate a certain number, you are going to substitute the x for that value.
right, so use substitution to basically evaluate the function by substituting in whatever the x value is. Okay, anything else that you think they might need to be able to know?
they have to, before they can do that, they have to know like what's the setup of the function. So that goes into function notation.
So understand function notation. Great, and then there's a standard that comes before this where they're not using functions but just around expressions, right?
Mhm.
So I think that's like the SSE
Yeah.
E1, right? So I think like there's and they typically do that before they would do the functions,
Yes, sir.
right? So kind of like how do you interpret, they need to know how to interpret an expression, right?
So identifying the different parts, like what does a coefficient mean? The
Yeah.
exponent and
Right, because once you have the function in there, they're essentially just evaluating an expression in function notation, so they have to know that before.
yes, sir.
Great. And then, is there anything else, like, if we go to what they need to show, so on their papers, when they're using function notation to evaluate, they need to use substitution. Anything else that you want to see on their papers, or when you think about where they struggle sometimes, that they need to be able to do?
I've seen how they know what substitution is, right?
Mhm.
But it's like when they substitute it in,
Mhm.
it's like they don't replace the variable x with the number. It's like they don't put it right beside it.
Right, they don't, yeah, so they don't know how to put it, or sometimes they get the signs confused,
Yeah.
right? Like, so I think, what if we call that just like fluency, right? Like fluently evaluate, yeah. So they need to basically know how to fluently evaluate a function. Like, they have to know that they have to plug in, and then they have to know, once they start to plug in, how to do all the mathematical pieces to get it correct. Okay, and then annotations, we'll get to annotations in a little bit, because we haven't talked about any problems yet, we're just on the standard. So anything else you'd want to add to this know and show chart? And what we're gonna do in a second is look at the actual the problem that we're looking at, and we'll come back and see if anything else needs to be added. So why don't we do that? So here was the task. Let me just pull it up here. Okay, so let's look at the task and then an exemplar response. This is my exemplar work, so if you think that there's something that I'm missing, definitely let me know. But what I want you to do right now is take a minute to review the task and the exemplar response and see, is there anything that the task makes you think we should add back to this chart, right? We're trying to add more to this no-show chart. So take a look at this exemplar response and think about what else do we need to add to our no-show chart.
Definitely that table.
Yeah, actually, so take a minute on your own. Right on, but take a minute on your own, and let's just think about anything else you want to add to our no-show chart. Okay. Seth, you want to start us off? Anything you noticed when you looked at the actual specific task from your class that we want to add to this chart here?
So, representing the whole work on the table, like my brother said, they need to know how to do that, where the X goes, and then where the function notation also.
Yeah. So we could put that under the writing problem solving. So like what do you call that table? Just the function notation table? Great. Okay. Or input output table, yeah, great. Okay, so they need to be able to do that. Anything else that you all saw?
Also, they kind of forget that, yeah, it's the functions, it says f of x equals whatever it is, but they tend to forget that f of x is also equal to y.
So I'll put that over in the concept side, yeah, right. And then it doesn't always have to be f of x either, right? 'Cause this one I think is u of x, so they just have to know that like those are interchangeable.
Yeah.
Right. Okay. Any annotations, like anything you'd want them to write? I put one type of annotation in this exemplar about how they like mark up the problem.
I like, is that Cadence Clark?
Yeah.
What's that?
Cadence Clark, I like how she put the line through all her equal signs too.
Oh, you're already looking at the students. Great, yeah, you're looking at the student exemplar, that's perfect, yeah. What is she, why do you like that?
It's like she's separating the function notation from the actual expression.
Okay, so like a separate function notation from expression. So that you can kind of break it up and make it just be an expression and solve it that way to kind of break it up in your brain. Great. I love that you all went to the student work because that was my next question, which is what anything in the student work that's strong that you think like would push our thinking. Anything else besides how she broke it up that way?
When they're substituting, like how after they make their substitution, they put that value inside parentheses.
So like really step by step. Yeah.
K did it well.
So step by step substitutions. I think some, as we'll see right when you look later, somebody could just kind of put it in and try to do the rest in their head or did it in their calculator, and when they do the step by step, they're less likely to make that kind of mistakes.
Yeah.
Okay. Great. So I think this is good, and this just kind of helps us think about what the standard is calling for, and then what the specific task is calling for. The other thing I want us just to keep in mind, if you look up here, I pulled released EOC questions. There's 4 of them up here that are to this standard. Again, this task doesn't cover all of these because it talks about a quadratic and an exponential, but just take a look at these and then we'll talk about like what else do we see that this standard calls for, which direction is the standard going to go eventually. Take 30 seconds and check those out. me to zoom in. Let's see if I can zoom in. Is that better? So this is how, when we looked at the released EOC questions, and they say this is from the same standard, right? So what do you notice about these questions compared to the question from the exit ticket?
It goes into the third question. I think it goes with the 41.
Oh, it's number 41? Yeah, number 41 is definitely the closest, right? Where they have to substitute in 30 for X. Yeah.
Yeah, closely related to that third one. But with the other two, it's more of a word problem.
Yeah. So would you consider these questions to be more challenging or less challenging than the exit ticket question that we're going over?
Those are more challenging.
Right. So what we want to keep in mind is, as we look at this exit ticket, that's part of the way for what students need to do, but what the standard really calls for and what the end of course exam really calls for is actually a whole nother level of understanding. Because in question 41 here, they have to know that when they see G with sub 30, that represents the X, right? Where in this exit ticket, it tells them what it represents. And then the other ones are all word problems. And they get into different types of like harder functions. So just something to keep in mind when we're looking at a standard, that we don't just want to assume that our exit ticket covers all parts of the standard. We want to make sure we know where do our students need to go to get all the way through. So we're not going to address these questions today, but I just wanted to put it out there so that you can keep them in mind as we're thinking about how to help the students. Sound okay? Okay. So we've got our no-show chart up here. We've unpacked the standard. We've looked at an exemplar response. We looked at the student exemplar response. And so the next thing we need to do is figure out where our students are struggling. And so to do this, you got a question?
Another thing with those questions, something I've seen is we give them mostly F of X, but as soon as they start to see like C of M and A of N, it's like they get kind of tripped up.
So they need to know that those are interchangeable, right? Yeah. That they're just random or letters that we need to know how to substitute in. Yeah. So how could you, well, I'm not going to get to how we can address that, but let's come back to that though. Because I think that's an important thing for us to keep in mind. And that's what we have up here, right? Which is that like F of X equals Y, but also that we can add that there's other ways that it can be notated too. So what we're going to do right now is we're going to each independently take a look. You have the packet of student work in front of you, and what we're going to do is go through and look for the gaps. So where did students struggle? And what we're eventually going to come up with is a statement that uses prompts that's going to kind of sound like this. We're going to say students struggled to do blank because they didn't yet fully understand blank. So that's what I want you to try to come up with. I want you to go through, analyze the work. We'll take about 5 minutes. I'll see if that's enough time. And then try to come up with a statement. Students struggle to do blank because they don't yet fully understand blank. All right? I'll put 5 minutes on.
mental health classes and one's focus on it. That was the rest of division.
And we're gonna take about a minute more, but if you look up here, as you're noticing where students are struggling, see if you can connect it to the no-show chart. So see if you can see what parts of what we said they needed to know and show are they struggling to do. Right, that was 5 minutes. Do you all need more time? Or do you feel ready to talk about it? Good? Okay, so let's just share out what are we noticing and we can try to connect it to this no-show chart that's great. Where's like the trending error? Where do you see the most common mistakes?
In the table.
The table.
Yeah.
So the function notation. How to plug it in.
Wait, say more about it. So one is that, right, a lot of the students who got it right kind of like inconsistently got the Y values, or like, there wasn't necessarily a pattern, right? They're all over the place a little bit in terms of the Y values. So what do you mean function notation?
Most of them was starting with how to plug in the values into the function. And then some were also finding it difficult working with negatives.
Mm-hmm.
And then some of them to it's like multiplication when they were multiplying by 0 and all that. So let's see that.
So I'm hearing plugging in correctly, and then also negative, when they do plug in, if you have a negative value, and that, we know that it can be challenging in all types of problems. Mr. X, would you?
Yeah, my thing is just, the tables.
So we see that they're getting a lot of students are getting the outputs incorrect, right? They're setting up the X value correctly, it looks like, right? The input is right, I think, in almost all of them. So the question is, why are they getting the output incorrect? That's what we need to figure out. Any hypotheses on why they're not getting the Y value right?
Like on Josue from, it's like at the very top, it says almost very partially proficient. It's like he substituted in -4, that's positive 8. So he had the correct answer, but when he put it in the table, he put a negative, is that a -50?
Negative 52.
Yeah, that's negative.
Do you know why? One of the things I have a question about that I'm hoping you all can help me because I couldn't figure it out. A lot of students put 4 on the outside. Do you know why?
I guess.
I thought that, yeah, sure they use, but this person look, the highlighting.
But like Leslie put 4, someone else here put 4, Josue put 4.
Yeah.
Copying it down wrong.
But over here, like even above Alexander, I don't remember what the name of that is, that student put 4. Right, so that's like, why, I was trying to figure out as I was looking at it, why would they put 4 on them as part of to replace the U? Or what does that show that they don't understand? I guess might be a different question.
That, they don't understand, the input, like the inputs and the function notation.
Yeah. So what I'm gonna do here then, in our no-show chart, I'm just gonna highlight, if I can. I don't know where my little, there we go. It's too zoomed in, let me zoom out for a second. So we're saying they don't know the input and output, right? So I'm just gonna highlight that so we can remember. And then we also said function notation, right? Because if they understood that, they wouldn't put a 4 and replace the outside, yeah. Okay. That's great. And then what about, I guess here's the same thing, understand function notation. When we think about what can we go back to what you were saying about the negative numbers? What did you notice there?
Yeah, so most of them were struggling with that because after the, if you look at, let's see, one student. Zedi, yeah, Zedi, I think, those who were almost there. After plugging in, the last one, she got it wrong, because after plugging in the 2, should have been -2 minus 4 plus 7.
Yeah, so she's getting the last
So
one wrong.
clearly here, she was struggling with the negative, working with the negative. Instead of -2 plus -4 making -6 and adding it to the 7 to make 1, she was writing +4 there. So it's like she was struggling with adding up the negatives.
Right. So just like the computational piece. So if you look at our writing problem solving part, which one of those bullet points do you think it would be that she was struggling with?
Fluency.
Yeah, fluency, right? So she's just like she knows how to plug it in, but then when she gets to plug it in, then mistakes start to happen. Cool. Okay, so I'm gonna highlight that as well. Great. Any other errors or gaps that you're noticing that students are having?
Some of them too didn't attempt it at all.
Yeah, right, it's hard to tell why, yeah. Yeah, when we get to like the back problem that we don't, and so that doesn't give us too much information of, or maybe they were just really struggling and we're like, I don't even know where to start, so it could be similar issues. Okay, so I think we have enough here to make our gap statement. So what we want to think about is how do we make a statement that fits into this language, right? Which is like students struggle to do blank because they don't yet fully understand. So let's start with the first part. So students struggle to what?
Evaluate.
Yeah, and we're going to use our language from up here, right? So we go up here because this is the show, right? So they struggle to fluently evaluate a function, right? Okay, students struggle to fluently evaluate a function. And now the question is why? Because they don't yet fully understand what.
We could say function notation,
Mm-hmm.
or we could say inputs.
Yeah.
Inputs,
Right.
outputs.
Like, do you think all of them understand what a function is? Like, if they're putting a 4 on the outside, do they know the input output? Right? They're not like I don't think they're all clear on what an actual function means. Right? They're seeing variables, but it doesn't. So, which is function notation, right? So you're saying they don't understand function notation. Okay. I understand function notation, and what is there anything else? Because they don't understand how to set it. So because they don't understand function notation, what are they unable to do correctly?
Substituting
Yeah.
correctly.
Yeah, so they don't fully understand function notation, like, or how to correctly substitute to determine if a number is a solution, right? To determine. Okay. How does that look? Does that seem okay? So we need help with what a function is and then how to correctly substitute it once, right? Okay, so we've named our biggest error the students are having, and so now comes the fun part. We gotta figure out what to do about it, right? 'Cause we could talk in this room and we could say, students don't understand this, and I think we all agree that, but if it doesn't leave this room, then it's not gonna help your kids. So we need to figure out how to get it back to the kids. And so what we're gonna come up with right now is a reteach plan. And here's the 2 options we typically use when we're thinking about how to reteach. So option 1 would be a guided discourse. That's like a class discussion where you might pull up from student work and ask students a lot of questions back and forth. And that's if you feel like a lot of the students have a pretty good grasp of the concept. The option 2 is modeling, where you feel like students are pretty confused and you need to explain step by step how they do it. So take a second to look that over, and then I'm just going to ask you which one you would choose if you have to choose one, guided discourse or model. So this is take like 20 seconds, and then I'll ask you. Okay. What would you choose?
Well, I will go for the 2, but if you ask me to choose one, then I'll go for the modeling, because the modeling, like, give them the opportunity to show them, demonstrate to them how I want it to be done, taking them through step by step for them to follow.
Gotcha. What would you choose?
I would do mine because I have to break mine step by step down my student.
I would definitely choose modeling as well, because it gives them an idea of how the thinking process of how to identify what function are we talking about, what value do we need to substitute in, why do we need to substitute that in, and then so on and so forth.
Yeah, and I think I agree with you all, and I think it also builds the conceptual understanding of like what a function is, because I think that they're missing that. And once if you can help them understand that, they'll be able to more easily substitute. Okay, so here is our job. What we're gonna do now is come up with what that model will look like.
Okay.
And so you all just have blank papers. You can write it. There's probably not enough space on the template. You can just, and if you need more paper, we can grab some. what I'm gonna ask you to do is write out how you, and remember, here's our gap statement, so that's the most important, thing to keep in mind, right? We need to help them first figure out function notation, and then have a substitute. There's kind of two parts to this model, function notation first, and then substitution. I want you to write out how you would do it, and try to write out like things you would say, right? How you would set up this model, the steps you would use to explain it to students. And then I'm gonna do the same thing, and then we'll kind of share our plans and come up with one together. Sound good?
Can you say that one more time?
So you're just gonna come up with, and I can show you, here's just some tips right here for modeling, right? So you wanna kind of narrow the focus to where the kids are struggling, and then you wanna come up with the steps that they're gonna follow. You're basically gonna show them how to do this problem, and you need to think of like, what are the steps, when they do this on their own, what are the steps I want them to be able to follow, and how am I gonna teach them that in this model? And the two key parts are right here, which is the function notation first, then how to substitute. I'm gonna put about 7 minutes on the clock, we'll see how we did. to have it perfect, so just try to get as far as we can. Okay, I'm gonna pause you where you are, and I think for the sake of time, sometimes what we have us do is like all swap our potential plans. What I'm gonna do is I'm gonna share with you a plan that I made when I was trying to think this through. So you're gonna pass down the screen. It's all in one. You keep them all together. Okay, that's one. There's not staple. All right. So go ahead, and what I'm gonna ask you to do is read over this reteach plan. And just think about like how does it compare to the one you made? What are some things that you maybe want to borrow, or what are some things that would make this reteach plan even better? 1 minute more to keep moving. Remember, this plan has 3 pages, so if you haven't gone to the next couple pages, keep on going. Okay. I'm gonna pause you there. Let's go over, when you looked at this draft reteach plan, what are some things that jumped out to you? Wants to start us up?
Okay. So, I like everything about it. Like, you basically began by redefining the vocabulary for them to understand what a function is, and also when I had to teach them how to notate it properly. And then after, you began posing the question, and after you pose the question, you use those who were able to do it properly to kind of correct those who are still not getting the question in class. And then after, you modeled one for them to see, teaching them where exactly they are to plug in the values they are expected to evaluate. And after that, you give them one for them to try, and then which is similar to the one you've modeled for them. And then as they try, you still went ahead to assist those who are finding challenges with that to help them out. And I like the way you went about it, and then also even the way you started with a problem that relates to them, the basketball question, it relates to them, so it kind of makes them have a perspective about the whole thing. It's real life problem that they can relate with. It's talking about the input and then the output. So it helps them understand it even better, and as it relates to their daily activities. So with this, whenever they get similar question, they'll be able to remark where the input, what the input is when the output will be, and then look it up. So yeah.
What do you think?
I think basketball game was a great idea because it let them understand that, like, if I shoot one shot, what I input when I shoot a shot, I know if I got 2 points, that's my output. So that was very good.
Right. And I did that's on purpose, because like, let's just do the simplest
Right.
basic thing, right? And that's what you do have to make sure you say there's no 3-pointers and no foul shots, but like, they were just taking field goals, 2 points, no matter what happens, that's gonna always come out the same. Any other thoughts, Mr. Jones?
What I like is, after reviewing, the previous question, you posed, a new question with a blank table, and, they were filling it in, and then for the exit ticket, you gave them, a more challenging problem.
Right.
Just to kind of see if they can take the concept that we just reviewed and apply it to this question. And also, I like the detail, and then the steps of asking the questions. So starting off with a medium, the medium skill student, and then asking. So after asking all those questions, calling on the lower level students to kind of give you a summary of what the discussion.
Yeah. Why wouldn't you just call on the highest skilled students first?
Because they
You're
already.
not worried about them, right? You already seen their work, you know they understand this, so you can use them to help other students and to push the conversation, but if you call on them first, it kind of shuts the whole thing down. So you have this data and you know which students struggle and you can think about how to use that to call on students. I think the last thing I want to highlight is there's the steps right at the very end where it says like, let's think the steps to follow. If you have those up on the board for the students afterwards, right, then they're going to be able to hopefully apply them one by one, like step 1, 2, 3, and 4, right? First determine what the problem is asking, set up the input-output chart, input the X value, and then write in the Y value chart. Hopefully they'll be able to see this is the steps that I need to do. Because when you model, you want to give students steps that they can replicate, so when they're doing it without you, they can do it. Okay, one last thing we got to do. We got to practice this a little bit. So you can think about how you can teach this to your students. So what we're going to do is we're going to break up into pairs. Maybe Stephanie and I can work together, and you two can work together. And what I'm going to ask you to do is just actually use this script and pretend like you're teaching to your students. And just kind of go through, we'll probably practice for about 3 minutes each, and just go through and kind of see how it feels to teach in this way, see where you run into issues or where you're confused about how this reteach plan is set up. And then we'll kind of wrap up after that. Because I want to give you a chance to see like, what would this feel like to teach before you go in front of your students and teach? Sound good? Okay, the other thing I'll ask is, and we'll do it, it'll be a little noisy because we'll be doing 2 different practices at the same time. Mr. Campbell, if you want to come listen in on this practice, that would be great. I'll ask whoever the teacher is to stand up and pretend like you're actually teaching. And then the other person who's kind of listening in can play the student and just give you any feedback, just because like, was this clear? Is there anything that you can do to improve as you think about how to teach this in front of your students? All right. So we're not going to get through the whole thing, but we'll go for about 3 minutes for each person, and then we will see how it feels. Sound good? All right. You're stuck with me, but you two can figure out who's going to go first. Yeah, you want to move over there? Do you have any questions before you start?
I wanted to know how to follow this airplane guide.
You can, or you, but it's, I want you to make it your own. So I think you should, if there's things you want to change, you should change it. And if you all want to use a whiteboard, you can put it back there. Feel free to do it. Let me just put a little time on the clock. What time do you all have to go back?
We got it.
Okay, I just want to go out. This won't take too long. I just want to make sure you're not stuck. All right. Well, I'll be a student, so I'll sit down. All right. Go for it.
Okay, so yes, I gave you yesterday on the web that I taught the function, how to run the function. I came across a few mistakes there, so I'm going to
So when I was reading the root entities, I know a few things. First, most of for education.
Let me stop you for a second. I think you want to be encouraging too. Right, so this part, like, you want to kind of say, like, I noticed that there was some mistakes that you also did, right? Because they didn't totally not know anything. You say, like, you almost got it, but today I'm going to get you all the way, right? So you want to encourage them so they don't just be like, oh, I'm messing up.
Let's take 2 minutes to,
okay, so
read the definition of function. A function is a group that reassigns to each input exactly one each output.
that we had few of them.
To help you see this, I go over
Wrong.
example.
So we are going to.
Let's think of it as a basketball game. In a basketball game, each shot that you make is worth 2 points.
There, then I
No
want
threes, no 3 points or no foul shots in this
Then I'll project this
basketball
one on
game.
the board.
The table below shows
Then
how many passes each
read
player
it
made
out and then it's.
and how many points they
So
scored.
go ahead and do that now.
Okay.
Yeah.
So the first go around,
So, in a basketball, the table.
Mr. Drew, he made 3 shots, so his input was 3.
And,
And so his output was 6
Sure,
points, so he
it's
scored
worth
6
2
points, because each point,
Mhm.
each basket made is worth 2 points,
yeah.
so 3 times 2 is 6.
it's 6. Yeah.
Ms. Kellogg, She made 5
is 10,
shots.
and the output for 10 is 20.
And her output was 10 points, so she made 5 shots, and her points was 10 points. 5 times 2 is
The
10.
player makes 5 shots,
And then
They scored 10
Mr.
points.
Campbell, he made 10 shots.
they score 20 points.
The output was 20 points, so 10 times 2 is 20, so each point is worth
Player base
2
is the
points.
input.
Mhm.
And then
As you can
the
see,
points
if a
scored
player
is
makes
5
3 shots, they score 6 points.
So,
If a player makes 5 shots, they
the
score
input is
10
also
points.
known as the
If a player makes 10 points,
and then
10
the
shots,
output
they
is
score
the amount
20
of
points.
values.
The amount of shots the player makes
So
is
at
the
this point,
input,
I'll call on one of the.
and the
call
total
me.
score is the output.
So,
Again, the amount, the number of shots they make is the input, and the number of points they score is
for each
considered the output.
output, how many possible
We can
outputs?
represent this function in
I think
functional
only-
as
I think only
f of x
one,
equals
right?
2x.
Correct.
Remember, 2x, we have a number and a variable, that's the coefficient, so 2
We said every
times whatever.
You can even ask me to explain. If I say one, you can say, well, give me an example. Why? How do you know that?
How do you know
With
that?
that,
Well,
one
because
thing I would think about.
every shot's worth 2 points. Whenever you make a shot, you get 2 points, and that's it.
What you
There's
did,
no other way. So
first
if
explanation.
this first person made 3, the only amount of points they could get is 6.
Now,
So that's, yeah.
good to true.
We know for how many shots you make, we know how many points you're gonna get.
They're engaged in
Right.
So let's try that part.
Okay.
Okay, so.
So just start, okay, so the input is 3 shots, I made 3 shots, and my points is 2 points.
So I'll call
Each point, so my output is 6 points.
Then I'll,
So true, let's say you make 5 shots, that's your input, what would your output be?
so you know, it's like 3 different students.
Yeah.
Medium scale,
Mhm.
another medium scale, and then the
What
lower
is your
scale.
Yeah,
output?
because what you want the lower skilled student to do is to listen and
Each
be like,
input
oh, I
is
can
worth 2
repeat.
points,
Yeah.
so
I
you make
understand
5
that.
shots.
Yeah, so why don't you try that?
What would be your output?
Okay.
Great job.
So based on this.
And how did you get that? What did you do?
We
What did
know
you
that
do?
a function is a root, then assign each input
Then 5 times
exactly
2
one
is
output.
10. Alright, that's what I'm saying. Alright.
There you go.
Okay, stop. I'm gonna pause us. We're gonna get to keep going.
Okay.
Why don't we go ahead and share any quick feedback and then switch teachers?
So, any feedback you
Okay.
get,
You get to keep going. Chris, you're with me, yeah, because I'm not gonna practice it.
So,
So we're here now.
So now that
And I know you're right, boy, so
That's the
Yeah.
key.
yeah, I was gonna do table.
Oh, see, let's call. So I would try to call on me to repeat that.
I was
Call
gonna
us.
say-
So I was gonna say, right?
So,
Based on my understanding,
we know that a
That's
function
what's real,
is a
that's
root
that's all.
that assign each input exactly one
Yeah.
output.
Step,
Okay.
so that
So,
when we get to the, now we start.
Put one thing in, you're gonna get another thing out.
That's what it is.
Right.
I'm not gonna get that.
Right,
Is that good enough for you?
yeah, I was gonna say.
That's okay?
that's okay.
Like, do you want them to use the mathematical language?
For a start, okay, they understand it, giving me this,
And so,
it's
Yeah.
okay.
I would say.
Then now,
Because I think that if I say if you put one thing in, you get one thing. I want you to push and say, what do we call the thing you put in, and what do we call the thing that comes out? So try that. So ask me again what the definition is.
okay, so,
A product.
It's where you put one thing in and one thing out, like one shot. You make a basket, you get certain points.
Your first
so,
explanation, and
one
then
name
from
for
there,
mathematical
with the visuals,
vocabulary,
and
can
then
be
you want
used
to
for
add.
the one that you put in.
To start asking the question.
Oh, that's the input. We put it in.
Nine examples,
So input,
and ask this question.
okay, any other,
And then all of
If you wanna
them,
use a variable.
so let's show you, so now also a visual aid.
Oh, well, X is what we use.
Okay.
Yeah. So X is input, and then
and then the output will be,
the output would be Y, or like the function, whatever.
so, now that we have reviewed the definition of the function, let's think about how we can evaluate the function when given an
When
input.
I reviewed the results of your
So, let's use,
exit tickets from
the same
yesterday,
example example.
I noticed a few things.
So in the example,
So for the
the
most,
function
for
is
most of you
f
guys,
is equal to
you got at
2x.
least
So here, the
problem,
f of x
which is good, that's a good start.
represent the
So
function,
today, we're going to review concepts
it's called
from exit tickets so that we can move on.
the y.
Most of
Yeah.
that
That's
is
the output.
partially correct
we
too.
can say
Most
y
or
is
all
equal
of
to
you got
f
the
of x,
question correct.
which is equal to
Sound
2x.
Yeah.
So the x is the input
Alright.
and the y is the
So
output.
functions
Okay.
are a foundational
One of the easiest ways to
concept
keep
in
track
math.
of our input
So
and output
concept, we're able to
So I'm
move on
going
to
to
the,
project it
to
on
the
the
next level of function.
Then I'll tell
So
you,
I
remember the
want to make
number
sure
of
that we all have a solid understanding
is
of
our
what functions
input,
are.
and the number of points is the
Evaluate.
output.
Okay.
So if our basketball
Now,
player
before we
makes
get
one
to the
shot,
problem itself,
it's
let's
called
take a
2
few
points.
minutes to
Okay.
review
So we go ahead
the
and then.
definition.
So let's follow me. Yeah, I'll be the same too. Or Natasha can also be the same.
Alright,
A function is a rule that assigns
so
each input exactly one
basketball
output.
player makes 7 shots.
So,
How many
see
points
this,
is scored?
I'll go over it quick as that.
14.
So, I like to have the concept of thinking of a function.
It's correct because the shot is 2. So
You
it's
have
7
to
times 2.
bring the machine to
Then
get something out of the machine.
use first name.
We
Yeah,
all know
my
that
student.
Yeah.
If a basketball player makes 4
Type in
shots,
code,
how many points
type
will
in
it?
code,
8.
outcomes the snap.
How do
So
you
in
get
a
it?
basketball game though, each made shot is worth 2 points. There are no 3-pointers or foul shots in this example. So something close to, was that?
Input and so forth.
So
That's
Yeah.
how it works.
Yeah, that's good. Yes, if you want to get the 50, that's it. Good.
That's
Okay.
forward. So it's stable, as you guys can see.
So now back to
So-
the
Yeah.
how do we define a function?
Shots
That's
made.
yeah.
This is our.
Since we talked about this earlier, you put an input in
then
and you get one output. So that's like there's only one option that could happen. Each time you put it in, you can only get one output.
This is our.
So at this point, I'll be looking out for the right.
This is our output.
Yeah.
So
That's your job as a teacher because kids may use different language where you want to stamp the input out. If you keep saying it enough and you have it written in your chart like you do here, then you don't get students to use that language. So like that's where you hold a high expectation and don't feel worried about pushing students to use that language.
There are 5 shots were made. How many points?
So yeah. So in a function, what variable represents our output?
15.
Would be 15. So why would you say?
So
And if she gets stuck, right, you've got a table, you can get a show her, so that'll be up
You
to
said
the
3-point shots.
Yeah, so for
So
2.
what are the steps to
Oh, okay.
evaluate a
Every
function?
2, every 10, 5 and 2 is 10.
Quite good. So,
I think
What
they
makes
added
it
to the
easy
step
for
first
us?
Okay.
before I ask them.
Yeah.
Because you told us initially that each
So I will
shot was worth 2 points.
write one question.
So if each shot's worth 2 points, and I make 5
I will
baskets
also
with 5 shots,
write down
then that's
the
gonna
value
give
or the
me
number I
5
want them to evaluate.
times 2, which
And I
would be 10.
will model
Okay.
to them for them to see step
Good,
by
much
step.
up, much up.
And
And
after
for
that, I will go to
10
the
shots
steps.
made,
What are the
Mr.
steps we take to
How many
evaluate a
points you
function?
got?
And you should be able to.
Yeah, and once you have it, you want to keep these up, right, so they can see them, so
So,
like
from
have them
this-
on a chart paper or something. Okay, great job. Pause, maybe, let's stop you over there,
Do a little wrench here. So
Mr. Campbell. I'm gonna pause you and come all back together. 30
30
seconds, go. Guys, thank you for practicing this up here. Is this okay? Yeah, okay.
Yes.
Because you have to explain it to us, because if you don't, then process.
Yeah, what was it, I was when I was explaining, so I was looking at other examples, it was about parking. One I thought was about a parking meter, I was like, they don't drive. They don't know, they might know what a parking meter is, but they may not, but they don't know how to shoot basketball, right? So let's try to, we want to make sure that it's sometimes you can find it, folks will give you an example about things that they experience around here, and so they're going to need to be.
Yeah, that's excellent.
All right, let's come on back, and we're gonna wrap up. Very quickly, let's do a quick debrief. What are your takeaways from seeing this reteach plan and practicing it in terms of like, what do you want to remember to do when you reteach this with your students? Mr. X, why don't you start us off?
Definitely, so for me, I would say just staying calm, and then, I would just slow my speech down, that way you can, allow the brain to comprehend what we're going over at the moment, and, also just being more detailed, when it comes to explaining like what exactly, so starting off with the definition, so, and that's something I like to do anyway, So starting off with the definition of a concept first before we actually get into examples,
Mhm.
and just taking the example and making it more personal to them.
Yeah. So I think for you, as you think about your planning, like this level of detail is helpful, if you're saying,
Yes.
and it takes some time, right, to put a plan like this.
Yeah.
But it also allows the more planned you are, the more clear you're going to be with your kids.
Yeah.
All right. What's your takeaway?
Going step by step and being very detailed and having a vision for them, they need to be able to visualize.
Great. What's your takeaway?
Yeah, I share the same idea with them. Relating it to real life situations, what they experience in real life, and then also being detailed with what they need to know about what a function is, and then how to notate it, and then how to evaluate it as well.
Great. Yeah, I think for our students, this is something about we want them to have clear steps they can follow because they're not going to have you with them, right? And so you need to make sure that they have those steps from the model. Great. Thank you all for participating in this. Is this something you could see being helpful if you were to do it like with your administrators here, like maybe once a week, once every 2 weeks, to pick a problem and review it and think about how to help students with it?
Yes, sir.
Yeah, very good.
Okay. Cool. Well, I appreciate your time. Sorry if I hope I didn't make you wait for, I know you gotta go. So, appreciate it, and thanks for diving in. And I would say just let Mr. Campbell know when you think you're gonna reteach this, because it'd be great for your administrators to come in and provide more support and kind of see how it goes.
I'm actually about to go ahead and apply this ASAP.
Okay. Great. All right, well then you know where you're gonna go, Mr. All right,
I want to see.
what are you thinking about doing?
Maybe that would be my next, because I've already I retaught it some time ago,
Yeah.
and then I also used the EOC questions as well. I think Miss Katasha will observing that. So probably my next lesson, the essay ticket that I will pass out, the mistake that I will realize, and then I will use these strategies.
Great. Yeah, you can apply this anytime students.
Yeah.
Yes.
Great. Okay. Thank you so much for coming. Have a good weekend.
Thank you guys. Thank you guys.